Welcome everyone to the 42nd live stream in our space shooter DevVenture. So in our last session, I was busy loading the scene files and script files on the operational layer for the combat system, right? So combat patterns and such. And I said I would add it in after the session, but I didn't actually get around to doing that. I was busy with some other things, unfortunately. So I'm just going to quickly upload them now, and then we'll move on with all the other stuff. Okay, so let me just check what I added in last time. I attached... Does it not show the attachments? Okay, let's just ask, which files did I attach in the last message? Which files did I attach in my last prompt? It's not showing, and I don't want to re-upload any files. And I don't want to re-upload files, only ones you haven't seen before. You don't need to re-upload these files. Please proceed with the new files that have not been shared yet. So I gave it firing range, health bar test, and health.gd. Now I need to give it, in terms of components, general components. I gave it health.gd, but I didn't give it health.scene. Do I need to give it health.scene? No. UI. Health bar 3d.scene and health bar. Yeah, so let's do this. Show in file manager. Okay, so we've got these kind of like this. So let's do 1 and 2, attach them, and then one more, because we can only do 3 at a time. So we've got the health bar, and we've got the firing range. Now we need to give it projectile, let's see, projectile components, general components. I need to give it plasma bolt and target. But for now, let's just do plasma bolt. I don't think I can attach any more. Seriously? Only 2 files? Can't be. It can't be. You've already reached the daily upload limit for your plan. I could only upload 2 files. The rest are still incoming. Please keep an inventory of the files I've already given you. Right, so coming back to this, we need to give it target and plasma bolt. What? Oh, I see. Interesting. So I'm not allowed to, it's not per prompt, it's per day. Okay, so that's the limitation. One of the limitations of being on a free account with Perplexity. Okay, noted. It's the the limitation that you can only upload 2 files or 3 files a day. It's kind of annoying, but what can you do? Right? So I will have to, unfortunately, I will have to open these in a text editor, copy the text, and paste it each time. Let's do that. Let's do that. So, okay. I can no longer upload any files for today. Here is the text from the .tscn and .gd files instead. So the first one is plasma bolt.tscn. So there's plasma bolt, and the other one is target.tscn. And so just so you can see what I'm doing, here's the two I've given it, plasma bolt and target, and then there's also mining target and health.scene. Okay, and then I need to give it some more. So those are the general components, then there's NPC components, things like the NPC gun and the player gun. So let's do that, components, player components, player gun. So it would be gun-npc.scene. That's this one. And this one. Gun. Okay, and what else? What else? Let's see. I want the... So I've got the guns, I've got the plasma bolts, I've got the health. Now I need to add in NPC components, behavior components, general behaviors, shoot. Shoot.scene. Please keep a running inventory of all files I've shared with attached or pasted verbatim into the prompt. Previously attached, pasted file contents. Your running file inventory now includes all of these things. Okay, now I need to give it all the GD files. So let's just do that. I'm just trying to think about it. Which GD file should I give it? Behavior for the gun, behavior for the bolt, behavior for the player's gun, health display, behavior shoot, behavior target. Yeah, okay, let's do that. So behavior bolt. Here are some of the script files I need to share with you for a full context of the combat system so far. Okay, so this one is called behavior_bolt.gd. Right, and then this one is called behavior gun underscore npc.gd. And behavior gun player.npc, .gd. Behavior player.gd. Copy all of this, put it down in here, and then behavior health display. I think that's fine. Behavior health display.gd. Health display, copy this, paste it here. Okay. Then shoot and target behavior. Behavior underscore shoot. And behavior underscore target. Did I give it behavior target already? No. So this is behavior target, right? No. This is behavior target. Okay. I think that's it. For now, anyway. There could be more files, but process these in the meantime. Here's your updated full inventory of combat system files and scripts you've supplied for context, both uploaded, pasted, and newly added. Uploaded, pasted, newly added, and this list will be kept updated every time you share more files. Would you like a breakdown of the current system status with respect to responsibilities, missing pieces, given what's in these files? Or should I wait for more files before making a detailed analysis? Yes, wait for more files and then make a fully detailed analysis. So if we go into the scripts side of things, we want NPC or AI. What's in the NPC behavior manager? Let's see. Oh, that's the that's the tactical layer for the enemy. It chooses from the patterns which of the operational behaviors to call. So no, that's okay. We don't need that one. Control components, gun, bolt, player, gun, battle player. Here we go. Battle player, behavior battle player. We'll copy that. Okay. Here are some more script files. Behavior battle player .gd. Okay, and then control behavior, shooting, steering. Those are all the behaviors. Player mining, player behavior. So scripts, behaviors, component behaviors, behavior target, and scenes, components, general components, mining target. Did I give it mining target? Yes, I did. Yes, assume the .scene file. I gave it this scene file. I just need to give it the script for that. Globals, no. NPC AI, player, combat, camera, globals, resources, UI, utils. Wait, I didn't give it health display.3d.gd. No, I didn't. So let's give it that. Health display 3d.gd. Copy all of the health display code and paste it in. Hopefully this is everything now. Go ahead and do a full process on these files and let me know what is completed and what still needs work in the combat system. All right. So, based on all the scene and script files you've provided, here's a thorough assessment of what is implemented and what's still missing from your combat logic system. This review is mapped to your milestone requirements and thread responsibilities. Combat logic and system status. The completed and functional is the projectile and shooting logic. The plasma bolt, firing, speed, coloring, and collision detection are robust. Works for defender and pirate vessels based on these files here, right? And then the mining barrel only damages mining object group, and the logic is in place for continuous damage when spinning and in contact based on these files here. And then group-based damage restriction. Only appropriate targets take damage based on group membership. All right. Hit detection. So these are all still in the completed section. So there's completed hit detection. Physics-based collisions, area 3D and collision shape 3D are used for hit detection for both ship, combat, and mining based on these files here. And then you've got your health or damage system. All actors have health that decrements on a valid hit, with signals or events updating 2D or 3D health bars. And Health bar displays and updates are functioning for both 2D and 3D, and then infrastructure for healing is present, though full healing features are not complete yet. And then you've got player shooting controls, so the player can fire a plasma bolt with a cooldown and physical instantiation logic. And then you've got mining and extraction controls. Mining vessels apply damage to mining objects as long as the barrel spins and is in contact. Partially complete or needs some work. We've got an AI triggered combat pattern. The current status, there is no functioning AI enemy combat logic. And what does exist? We have behavior shoot, which provides a strong foundation for AI logic like shooting and aiming and line of sight checks and trigger shots. But there's no evidence in your code of a working AI manager or a pattern selector or integration with proper AI event triggers. Then we've got the healing system. That's the current status. The signal infrastructure is present, but actual healing logic like member implementations or triggers are missing and not hooked up in the gameplay. And then we've got expansion hooks for future weapons or effects. The current status, the design supports adding new weapons or effects like bolt color logic, group-based targeting, component-based behavior scripts, but there are no explicit code hooks or modular interfaces such as register a new weapon type or effect manager systems. And then status effects, buffs and debuffs, there's currently no implementation. Healing infrastructure exists, so adding effects like stun, shield, slow, etc. can build on that signal event pattern. And then intra-layer communication, we've got an event system. The current status signals are used for health change and destruction events. Target destroyed, health changed, but there is no code for structured communication between layers. Combat layer reporting its results to AI or tactical threads. The progress reporting, the tactical reporting infrastructure setup, but no implemented reports or progress blocker tracking functions. Missing or needs work, the status, and system components. I could have just gone through this table, to be honest. So the status is complete, there's plan code for this, partially implemented, and then foundational. AI triggered combat systems, we need pattern selection, activation, and integration. We have that, I just didn't share that, so let's share that. Okay, I forgot to share with you the strategic and tactical layers in the AI architecture, the enemy AI architecture. Here are the two script files. Well, maybe three. Here are, we'll just say here are the script files governing this layered behavior system. Okay, so the first one is the enemy ship controller.gd. And that's the auto load singleton. So enemy ship controller. We'll copy all of that and we'll paste it all in here like this. Then we've got the enemy behavior. Enemy ship behavior.gd. This is the actual logic that controls every enemy ship, and that's quite important. So we'll copy all of this. We'll put it all in here, and then we'll move on to the final one, which is the NPC behavior manager. .gd. And the NPC behavior manager.gd has this code here. Okay, and then we'll just say note that enemy ship controller.gd is a singleton called enemy underscore ship underscore controller in the project settings, and it functions as the strategic layer. and the npc behavior manager.gd script file is the tactical layer. All behavior scripts like shoot, like behavior shoot.gd are operational layers. The strategic layer interacts with the tactical layer, and the tactical layer interacts with the strategic and operational layers, and then the operational layer interacts with the tactical layer. Only adjacent layers can be interacted with. Please update your understanding of my progress with the combat system. Okay, with your addition of your strategic AI layer scripts along with the previously shared operational layer, here's an updated system-wide progress audit for your combat system. We'll ignore all of this stuff and we'll just look at the table, right? So your strategic layer completed, pattern orchestration, your ship and the waypoints, full multi-ship logic reporting, advanced operations, your tactical layer, pattern activation, event handling, behavior queuing, more robust activation reporting. So these are all in progress, right? So we need to work on these. And then the operational layer, shooting and mining and damaging health. In progress or needs work, advanced behaviors, healing status effects, and modular hooks. Priority next steps. Yeah, this is what we were working to get, right? This is what we put all this effort in for, is what do we actually need to do still, right? What are the next steps? What are the most important next steps? And what do we need to do to get them done, right? So I hope you can appreciate that this was the payoff, right? We did all that effort and now we're getting the payoff, right? So the priority next steps. You finish your advanced operational behaviors like AI-triggered combat patterns beyond shoot or seek, such as a multi-step attack, evasion, power-ups, etc. And then implement a full healing and status effect infrastructure with your operational layer. And then add a modular expansion for hooks or interfaces at the operational layer for easy weapon effect changes, like effect addition. So adding like electro bolts to, or EMP bolts or EMP missiles, you know, so it flies up to a specific target and it detonates, and then within a spherical radius of the detonation, anything caught within the blast gets like EMP'd, and then it stops moving, gets stunned for a few seconds, and it's a sitting duck. You could just bombard it, you know, or maybe it just wipes out the shields for a while and it carries on flying. If it has shields, maybe it carries on flying. If it didn't have shields, then it like becomes stuck for a few seconds. It like coasts and comes to a stop, no longer accelerates, can't steer, can't shoot, can't do anything. It just maintains its current velocity in whatever direction it is going, and you can just fire at it until it recovers. Or if you're talking about different weapons with different effects, you could have like a seeking missile, you know, a missile that chases after the target for a while. It has like a countdown timer, and it chases after the target. No matter where it flies, no matter what direction it changes, it continues to home in on that target until the time expires, and then it blows up, and then it detonates. It goes poof, and then anything within that radius takes damage. So you could do that, and then yeah. So we've got some ideas we could use, and there is some promise in those. Now, I'm just trying to think about this for a second. Oh, yeah, okay, so that was the first one. Then we need to implement full healing and status effect infrastructure within the operational layer. Add modular expansion hooks for or interfaces at the operational layer for easy weapon or effect additions. Scale the strategic layer for a multi-ship strategic operation and high-level reporting. And then enhance tactical layer with pattern queuing, progress blocker aggregation, progress or blocker aggregation, and more detailed tactical feedback. So as you can imagine, this is going to be quite a lot of work, right? So adding all of that context was not just required, but or maybe it wasn't just helpful, but necessary, right? We needed it. It was compulsory to add, because not just for tracking our progress, we also needed it for giving it the context, right? So now it knows, oh, okay, so in the NPC behavior manager, this is where we do all the tactical work, and this is what we've already done, and this is what we need to do. So in the tactical script, you can add this function here, right? And we've already got these signals, they are already connected, so we could just use these signals and update their connection functions to add in whatever functionality we want, right? So there's a lot of potential here, and those 5 steps are not small tasks, right? So I'm going to have to take those priority next steps and break them down even further and work on each of those broken down steps individually until we finish it, right? So consider this next step, step 1, to be like a section in a book, right? If you're thinking of like a textbook, it should have sections, and then in the section it has subsections, and then in those subsections it's got like headings maybe, or just paragraphs, and then each paragraph has sentences, each sentence has words, each word has characters. So we want to get right down to the characters, right? To the point where well, maybe not right down to the characters. We don't want Perplexity telling us exactly what to do. Like if it's telling us in terms of characters, what does that look like? It looks like this. Create a mesh instance 3D and attach it to this node. And then create a new script and call it this. And then in that script, put this code, right? So that's like super low level instructions. And it can work, right? But again, you're not thinking in that scenario. You are not thinking as the developer. You are not doing any of the thinking. Perplexity is doing all the thinking for you, and then you're just an execution, a means of execution, right? So I don't recommend that. What I do recommend is that you let Perplexity manage the project. You let it be the project manager, and you focus on being the developer. So you keep track of as much as you can, humanly can, right? So you know the context of your scripts, you know where things go, you know how things work, you know where to add something, when you need to add something, how you can add something. All of those stuff are your concerns, and leave the rest for Perplexity. So let's start with priority step 1. Okay, finish the advanced operational behaviors. That's what we were busy with in the first place, right? Adding in the combat behavior. We were doing that. That was the last thing we were doing before we started working with Perplexity. Because if you remember, we were doing that and then we ran out of space on DeepSeek, and I got fed up that we ran out of space on DeepSeek. And so we spent some time doing this migration. Okay. And I think that's a fitting next place to start or continue, right? So let's do that. Okay. I want you to keep an inventory of these priority steps, of these so-called priority next steps, and we will work through them systematically. Let's get started on step 1. I consider the step 1 you listed as a so-called section in the book. And in the book metaphor. So please help me break this down into subsections so it becomes easier to identify the work that needs doing. Absolutely. Here is step 1. Finish advanced operational behaviors broken into practical subsections. What? No, it's not chapters in your book metaphor. Anyway, we'll just ignore that blatant mistake. Into practical subsections. For each, I'll provide a brief description of what that area covers, so you can more easily identify, plan, and designate smaller tasks or code modules, right? So step 1, finish advanced operational behaviors. Step 1.1 is to design and implement standard combat patterns, right? So create a basic combat behavior that AI ships can execute and define required parameters and results for each pattern. So create the basic combat behaviors like attack, defend, pursue, evade, and patrol, and then define required parameters and results for each pattern like inputs, outputs, status, completion, signals. And then 1.2 is the behavior sequencing and chaining. Allow an AI ship to execute sequences like attack and evade and attack. Implement logic for chaining or switching patterns based on triggers. Example, low health causes flee, right? And I think for chaining, we will need to consider using a graph. Okay? And for those of you who are not familiar with what I mean when I say graphs, let me just go back to that old drawing of ours and demonstrate what I mean by graph, right? So a graph in mathematical terms is not what you would consider a graph in scientific terms, right? It's not the thing with axes and plots, right? So a graph that you are used to most likely is something that looks like this. And this is actually called a plot. It's not a graph, right? So if you've got a thing that looks kind of like this, and then it's got x-axis and a y-axis, and sometimes even a z-axis, and then you've got some kind of line or shape or curve, right? So this is a plotted curve, a curve plot. So we'll do some kind of S-shaped curve. Starts off slowly, picks up, and then slows off at the end. Okay, and this is a plot. So let me write that down. So this is a plot. This is not a graph. In brackets, not a graph. Okay, Now, what is a graph? A graph is the following. If I change to this blue, and I zoom in somewhere over here, like that, so we kind of see where we are in space. We know where top is, we know where left is, so we have a general vicinity. Okay, so what we want to do is we want to draw a graph, right? So a graph is something like this. It's got nodes, and maybe one over there, and then it's got edges, right? Now you can have multiple types of graphs, but the best kind of graph to have in computer science, and by extension games, is a directed acyclic graph, right? So you want to have something that kind of so the edges, right? So these are edges and those are nodes. So something like this is a graph. Okay, and you could, in theory, let's just choose a different color. So let's do maybe like a red, right? And we could, for example, have an even more complicated graph where all the nodes are connected to all the edges, right? So this one connects to this one, this one, this one, and this one. This one connects to this one, this one, this one, and this one. And this one connects to this one, this one, this one, and this one. And this one connects to that one, that one, that one, and that one. Okay, so now they're all connected, right? And now you've got directions. Okay, so you can add in directions as well. So let's say this one goes that way. I want to switch back to a pin for now, so we know that we're drawing and not tracing out lines, right? And let's say this one goes this way, and this way, right? And let's say this one goes this way, and this one goes this way, and this one goes this way. And then this one goes that way, this one goes that way, this one goes that way. Okay, so this is a directed graph, but it's not an acyclic graph, okay? And what I mean by a cycle is there's this potential here, if you look carefully, for things to move in circles, right? So you could do a cycle here, right? It could go there, there, and back. Or it could go there, there, well, there, and back. So you could have a cycle like this as well. And I'll just draw that in a different color, something completely different, like purplish purple. So it can do a cycle like that, right? And it could do there to there. Oh, there to there to there and back. Yeah, so there's a cycle here too. So you can see the dangers, right? You could have quite a few cycles. And as long as you have cycles, you have the risk of having, the so-called infinite loop. And your program might never close. Okay? So you need to be watchful for that kind of thing. Now, that's what I want to design right now. So I needed to give you some context, right? When I said graph, I mean this. So let me write this in white at the bottom, like so. This is a graph. Okay, this is a graph, and this is not a graph. Now, let's design our graph. We want to chain patterns, right? So we want to have, maybe not patterns, but we want to chain operations into a pattern. So a pattern can be a graph of chained operations. So maybe the strategic layer can chain patterns and the tactical layer can chain operations. You know, it could happen. But anyway, the point is a chain is a graph. Okay? So when I draw this, I want to say, for example, let's do red and say attack pattern. That's a horrible T. Nope, that's still a horrible T. I'm trying to find a way to draw a T that doesn't need me to cross the T. But I'm failing, so we'll just do that. Attack pattern. Right? And what we want is, we want to do a seek. So seek the target. And that's in a box. And then we want another operation. So let me actually draw these in boxes. So if I do box, oh, I see, I took away the N. Okay, so now we'll go back to the white pen and we'll do a box here. So we'll do this is seek, and we'll just write that in. So seek. Okay, and then we want shoot. So we'll do a block for shoot, like this. Oops. I'll just draw this with my mouse. It's easier. So there. And then we want a block for flee. Like that. And we want some breaking condition, right? So okay, so then that's fine. We'll just finish writing this, and then we'll talk about conditions and joining edges to these nodes. So switch back to pin, and we'll call this flee. And we'll say this one is shoot. All right. Now I want to switch to yellow and draw in the lines. So there's a line like this, there's a line like that, and there's a line like this. Okay, and we'll say yellow is has a specific direction, right? So it has to have a direction, and we'll say that yellow goes in this direction. So in a clockwise fashion. So there's a clockwise cycle here. And then there's also red edges. We could have red edges too. So let's do a red edge like this. So this one goes like so. And this one goes like so. And this one goes like so. Okay. And those have the opposite direction. So instead of pointing this way, they point this way. And this way. And this way. Okay, and so that means we've also got an anti-clockwise cycle, so a cycle going in this direction. Right? And now we can write in the reasoning. So it wants to seek the target and shoot. So this is the red cycle. So seek the target, then shoot, and then flee, and then seek the target, and then shoot, and then flee, and then seek the target, and then shoot, and then flee, and so on, right? So we could call this the aggressive sequence. And if I zoom in here, we could say, maybe just zoom in a little bit, like this. We could say that the red one seeks the target to get close to, so 2 pixels. Here we can say this is to get closer to target. And then shoot so shoot over here can be to get the enemy within range, right? So once it's in range, then fire as long as in range. Fire while in range. It's a bit blurry, but I think it kind of makes sense. You can kind of make that out, what that says. And then here is to get away from target. Avoid return fire or collisions. Right, so get closer to the target, seek the target out, then shoot while in range, and then once you get too close, then avoid any return fire or colliding with your target. If the target is stationary, don't smash into it. If your target is not stationary and hostile, then avoid return fire. And then once you've gone to a safe distance, get closer to the target, shoot, and flee. Get closer to the target, shoot, and flee. Get closer to the target, shoot, and flee, and cycle, and cycle, and cycle, until the target is destroyed, right? And so we need to have a break node somewhere, right? And I think the break node should be somewhere over here. So here's what I'll do. If I go to tool options, I could say background color, and I can make the pen color black, and then I'll just erase this. Never mind. Foreground color. There we go. Nice and clean. And then I should have done that in the last session. Anyway, I need to switch to no full again, and then change the pen color back to white. And here we can see oh, because it's on 2. It's a thickness of 2, so we'll make that 3 again. So let's do a close of a closing brush. I mean a closing box here, and we'll say this is the break node, right? So break out of the behavior, the pattern. We'll call it the break node. Okay. And each of these needs to access break at some point, potentially, right? So you could break from seek, you could break from shoot, or you could break from flee for whatever reason. And so now we need to choose a separate color that isn't yellow or red. And what I want to do is I want to go with blue. So let's do this. Let's say seek can escape to break over like so. Flee can escape to break over like so. And shoot can escape to break over like so. And the direction, of course, will always flow towards break from these nodes, right? So I'm just going to zoom in here. We'll just throw those arrows like this. So it's fine to have a cycle as long as you can break out of the cycle safely all the time, right? Unless there's a condition to break out of the cycle, you should never have a cycle. But if you do have a condition to break out of the cycle, you still shouldn't have the cycle, but then it becomes okay. So, as a rule of thumb, just don't have cycles. But in a game, especially in a game, that's not always possible. You kind of do have to have cycles, especially when it comes to animations. Then you really do need to have cycles, and it makes sense to have cycles, right? But yeah, in pure computer science, cycles are usually bad. Anyway, that is a digression. So we want to have reasons, right? We want reasons for breaking out of the cycle. So when seeking, if there is no target to seek, right? So here we'll say no seekable or no target found. No active. No, that's way too small. So we'll have to write it a bit bigger. So we'll say no active target. Okay, so when no active target, break. Don't seek anymore, just break. Right, and then flee. Nothing to flee from. So over here. Oh no. Okay, here we go. We'll say here. Nope, that's a terrible in. Like so. Say nothing to evade. Okay. Here we go. Nothing to evade. So we'll draw an evade. And we'll just go in and clean that up a little bit. So So when there's nothing to evade, then break, and then the shoot should have another context, nothing to shoot. So here we'll say we're there. Again, no active target. So we'll say here nothing to shoot. Like that. Okay, so this is a behavior pattern. So this is the attack pattern. We'll draw this in red box. Like this. Nope. So we'll start it here, then we can kind of see where the box should fill in. Like that. Right? And then we'll just do that again over here. Just to illustrate that's the attack pattern. So this is what I mean by behavior patterns and operation chaining. But as you can kind of see, we have run out of time. We've reached the hour. So thank you so much for your time and your attention. I'm going to make a shout out now to Cubes. Thank you so much for your support. He is our junior DevVenturer. And the rest of you, if you want to support the channel, consider giving the video a like, subscribe to the channel, and sharing this link with as many people as you can. Okay? If you want to donate financially to the channel, you can visit the Coffee page here at the bottom and become a member. Or you could just do a one-time donation. I appreciate it very much. Thank you so much. And once again, thank you for your time and attention. And I'll